Let us learn about the iterated elimination of dominated strategies. The question is, in a two-player game, player 1 can choose either M or N as strategies. Player 2 can choose either X, Y or Z as strategies. The payoff matrix is as follows. We need to find the strategy profile that survives the iterated elimination of strictly dominated strategies. Okay. So we have player 1, he has two strategies M and N, and player 2 has three strategies X, Y and Z. Um, okay, this red color elements in each cell denote the payoff for player 1, and the green color elements in each cell denote the payoff for player 2. Okay, we need to eliminate any strictly dominated strategy here. First we should know about what is meant by dominance. Okay, what is meant by dominance, and let me explain it here. Let us say we have player 1, any player, and he has two options, two strategies R and S. We are not talking about player 2 here. I am just taking it for the sake of simplicity. Let us say player the strategy R gives him 10 and 5 as payoff, and S gives him 3 and 4 as payoff. Okay, now dominance occurs when one strategy is better than another strategy for one player, no matter what the opponent player plays. Here you can see playing R is always better for player 1. Okay, so here we can say that this R is strictly dominant strategy because 10 is greater than 3, 5 is better than 4. So playing R, we say that R is strictly dominant strategy, and this S is called the strictly dominated strategy. Okay, that means strategy S is strictly dominated by strategy R here. Okay, our endeavor is to eliminate any strictly dominated strategy. Now let us see here. The question is, does player 1 always choose M? Okay, here you can see, let us see, when player 2 chooses X, player 1 can choose either M or N. Here you can see 3 is greater than 0, so player 1 chooses M. Okay, fine. When player 2 chooses Y, player 1 chooses N because 1 is greater than 0. Here we can see player 1 is not always choosing M as strategy when player 2 changes its strategy from X to Y. So we can say M is not a dominant strategy. Let us see whether N is dominant strategy here. And here we can again see that when player 2 chooses X, player 1 chooses M. When player 2 chooses Y, player 1 chooses N. So the strategy of player 1 changes with the strategy of player 2. We say that neither M nor N is strictly dominated strategy in this case. Okay, now we need to ask this question for player 2 again. Okay, does player 2 always choose we are comparing strategy X and strategy Z of player 2. The question is, does player 2 always choose Z strategy compared to X? Here you can see when player 1 chooses M, player 2 will always choose play Z because Z gives him 2 payoff, X gives him 1 payoff. And when player 1 chooses N, player 2 will again choose to play Z because Z gives him 1 payoff, X gives him 0 payoff. So 1 is greater than 0, 2 is greater than 1. We say that Z is strictly dominant strategy, which implies that X is strictly dominated strategy. So here we say that X is strictly dominated strategy, and our endeavor is to remove the strictly dominated strategy. So how what about we know that in this case we assume that both the players are rational. That means each player knows that rest of the players are also rational. That means if player 1 knows that player 2 is rational, then player 1 can eliminate X from player 2's strategy space. So we eliminate this this column here. Now we rewrite this like this, and again see whether any player has any strictly dominated strategy. And here let us see from player 1, does player 1 always choose M here? So let us see, when player 2 chooses Y, player 1 chooses N. So we say no, it is not strictly dominated or dominant strategy. Now does player 1 choose always N when player 2 chooses Y or Z? So here you can see when player 2 chooses Y, player 1 chooses N because 0 is less than 1 or 1 is greater than 0. When player 2 chooses Z, again playing N is better than playing M because 0.5 is greater than minus minus 1. So we say that N is strictly dominant strategy, which means M is what we call this, M is strictly dominated strategy. Okay. If N is strictly dominant, it is inverse will be that M is strictly dominated strategy. So we again eliminate this row here. So we are left with player 1 with only one strategy N and player 2 with strategy Y and Z. Again we need to check what happens. So player 1 has only one strategy, that is N, and player 2 has two strategies, Y and Z. So let us see, when player 1 chooses N as strategy, player 2 has two options, either to choose Y or Z. Here you can see playing Y gives player 2 more payoff than playing Z. That means Y is dominant strategy and Z is strictly dominated strategy. Our endeavor is to remove this dominated strategy here. Okay. So then we are left with only this very strategy profile, that is player 1 will choose N and player 2 will choose Y as the strategy profile. Okay, so this will be the equilibrium in this case. I hope I make myself clear. Thank you.